Good morning. You'll excuse me, I have a little bit of a cold and probably will be coughing and sneezing and all the like during the talk, just as a word of warning. I hope the viruses won't reach you through the mic. So basically what I would like to make is an introduction of how my views on the how network service management can be achieved, taking into account that we are evolving through something that is a network based on software. And to start with, it is about thinking how we have now the network. The network is ossified, and this is something that should not be necessarily bad. I mean, the ossification is the process in which the cartilage becomes bone in most mammals, at least in humans, and when we get old enough, all of our skeleton or basic structure is hard enough to hold the rest of our body and to move around and to stop growing, because growing without limit can be even dangerous. On the other hand, is when we get older, we lose a lot of flexibility, agility, adaptability, and capacity of growth. Basically, translated into what's the situation right now in the network is something that so far we have everything baked inside the infrastructure. Nothing is outside the infrastructure. Everything that is told to be managed outside of the infrastructure, you find a lot of resistance, because there is this general belief that everything has to be implemented by a protocol and connected via the interactions between two nodes. We have standardized everything, every single bit, every single process has to be standardized, agreed, aligned, and if you try to derive a little bit for that, even in these good days of open source, you are accused of fragmentation. That goes very much beyond what is the requirements for interoperability, and limits a lot of differentiation. This diagram there, that is supposed to be the diagram of a 3GPP LTE network, is precisely intended because no operator in the world dares to go away from that. What means that everything that every operator in the world has is exactly the same of the other. And you can differentiate, well, providing a better services in some places, or having a nicer customer relationship people on the phone when there is a problem. No more than that. And that implies that, well, it is an industry with a mentality that is very reluctant to change. Not only operators. I mean, for vendors, it's extremely comfortable. Operators are structured, vendors are structured, regulators are structured, and even customers are structured around the same idea that we have the RFIs, RFPs, RFQs, everything is organized like that. All our internal organizations are like that. Any change is complicated, long, costly, if even possible. And well, it's because it's the path of lowest resistance for all actors, including the OTTs, because for them it's extremely easy to have a rigid substrate that is sustaining them without being able to change with them. And well, here comes virtualization. This is something that we have shown many other times. Is when the virtualization came with the idea of providing the possibility of bringing this software in the network built on software. So we have NFV dealing with elasticity and addressing heterogeneity, and SDN, so you can gain programmability on one hand and the ability of abstracting the infrastructure through software constructs. And that brought us the possibility of going much faster into automation, and the possibility of taking advantage of these additional properties to try to de-ossify the network and try to make the management more agile, more efficient, though always it will have, I'm sorry, Klaus, about that, there will always be a human in the middle. One way or another, we need a human. I mean, with some extent, the number of humans for sure should decrease, and the number of human interactions necessary for performing a certain task should decrease. But we should take into account that this is something that will always happen, well, we can take advantage precisely of the properties that we were sitting before about elasticity, homogeneity, programmability, and abstraction. And something that is very important and that I really miss when I attend to talks about whatever, SDN, NFV, service management, whatever, I tend to miss that people apparently are not realizing that change is not only happening here. I mean, it's not only that we are changing the basic technologies that support the network, but it's the network itself is changing. The internet stack is evolving. The usual IP, TCP IP, and that when I was younger, I was about to say when I was a kid, but when I was a kid, there was no internet at all. So, but it's so long ago, you know. The old TCP IP is changing. This is right now, according to our statistics, and taking into account that the traffic is dominated by one or two main providers. Quick is right now accounts for, if I remember well, depending on the zone, between 15 and 20% of the traffic, because Google is forcing Quick in both ends of the connections, and so you have something that is not TCP IP any longer, it's UDP and you cannot distinguish, and is encrypted, and everything will become encrypted end to end without any possibility of applying the current techniques for network management that we have. Somebody was asking about data. It was Ray, if I remember well. The problem is that if we have most of the data that crosses the network passing by on encrypted UDP streams, it would be almost impossible to derive any data that makes any sense for the current way of managing networks. Well, and for sure, we will have 5G with all these billions of machines running and generating data and making even managing, collecting those data and taking management decisions basically impossible, because there would be no storage in the universe to register all this. And this is something that we have to take into account. It's not that we are the ground on which we stand is changing, is that everything is changing, the atmosphere is changing, the goals are changing, the directions that we have to move is changing. We are addressing at an extremely moving target. Well, in this respect, what we have is that the software principles, the ideas of bringing software onto the network and building the network following software development principles are very appealing. That what you have at the right, on the left, is an original proposal we made a long time ago about how to structure network, in general network, and in particular network management, following sort of an operating system structure that probably is a little bit outdated because the idea of the operating system is a little bit too narrow, but still is there, and I like to use it to illustrate how ideas were 5, 6 years ago. Now we are thinking more in terms of going beyond the operating system concepts and going beyond other constructs that IT allows, like compositional mechanisms, model-driven, DevOps, the usage of integrated environments, and well, who could not cite the ever-present machine learning and artificial intelligence. I try to use a different term just to avoid the AI. That is okay. Just a review on some of these technologies when it comes to composition. Something that is quite curious is that for quite a while there is I guess that most of you know a guy who's called John Day, who's the sort of the father of something called RINA. He was, one of the things he always complains about is that in current networks, there is this way of thinking in which everything has to be built like birds on a string. Everything in a direct, which is the name, sequential succession of elements. This probably is true when you have those elements are expensive boxes that have to be connected using expensive pieces of fiber. But right now, if you have software, if you have something that is ductile, you don't have any need to do so. You can do things in parallel. You can try to achieve several goals at the same time in parallel. It only costs another piece of code running, and you can try to make a composition afterwards. It's a way of changing the way of thinking, and changing the way of thinking not only about how to build things on the network, it's about the kind of things that you can put on the network, which is important as well. And for sure, when it comes to management, that includes element managers. There is this OSS, EM, network function successions, beds of a string as well. These 3 beds on the management string. You don't need to have the element manager and the necessary mediator of everything. You can think of an additional component, of a general or particular policy translator, an autonomous agent, or whatever you like in the middle. The idea is that you don't need to be stuck that in the moment that you deploy the network function, you need to deploy as well an element management that will take care of translating what the OSS says, etc. The architecture should be much more free in that respect. And well, for sure is about model-driven development, and as you can expect, this is part of what I think is one of the archetypal cases of model-driven development. That is our OSM, in which you are able to, the idea is that you're able to move from the local development up to the actual deployment, consistently keeping the same model, because what you're doing is that you are describing what you want to achieve, and you are moving what you want to achieve from your development environment to a lab environment, to a further validation, to a final environment in which you make the actual deployment, being consistent with the descriptors of the services and the functions and how they are composed. And this is where the previous idea of the composition meets this model-driven. This is another case in which is very important. That has to do with what this, somebody was asking as well about cloud nativeness before. It's precisely about the possibility in which, thanks to the ability of working in terms of model, you can expose a set of high-level primitives that can be subject to invoke them for those managements. And what is important is that this set of high-level primitives, in principle, don't need to be fixed in the sense that you have only a set of things that you can manage. You can announce what you manage and dynamically decide how you compose this to build a service and to parameterize the service. And you can think of managing it precisely using cloud native methods. What is now used to manage cloud applications rather than this right now used to manage network services. Is be consistent, same day use mechanisms, use the same data models. Something that is connected with this somehow is the idea of the DevOps. DevOps is very appealing. DevOps is very promising. DevOps is extremely, it's one of the buzzwords that you use continuously, say, we are going to make DevOps. And then somebody tells you, hold on, we are an operator. We do ops. We don't have developers. And even most of our developers are third parties. And even if we are talking about those who are working for us, they are considered third parties because operations, in our case, I mean, in the case of the operators, is highly regulated, is part of what is supposed to be critical infrastructure. The kind of rules we follow is not the same as like the glitch of Amazon Web Services a couple of years ago that put Netflix out of the network for a couple of days. If the mobile network goes out of work for a couple of days, imagine where whoever suffers this, I can imagine what would happen to me. I mean, my company would close, simply that. So it's something that you cannot afford so much, I would say, happy DevOps. You have to be much more careful, and this is why we are experimenting with this idea of separating this by a mediation mechanism in which what you have is a service development kit for developers that restricts what the developers can do and how they can do it and move them in a certain direction. A control service platform for operators that has a direct mapping to what you can do at the SDK, and something that we call the gatekeeper to make all the verifications, and what is something very important as well, to guarantee traceability. So you can know who caused what happened, because having someone to blame, in some cases, is very important as well. And that's comes to this idea that we need a human in the loop, always. You need someone that takes the decision, you need someone that is, and that is, I mean, at the end, is legally liable for whatever happens on the network. And is when you need that the human can be integrated in the loop and the human can know what's going on. And for that, well, it's not so unusual that we think in the same terms as software, and we're talking about, well, that those two images are from a project we finished some time ago that was called NetIDE, and that originally was called NetClips, because the idea was precisely to follow the same philosophy of Eclipse, in the sense that to have an integrated development environment where you have a single entry point, and you can even think about application and network code design. If you have the flexibility, you should not have to say, hey, my network is this, I have a socket, I open the socket, I throw things at the socket, eventually they will arrive at the other side, and the other end will respond, I will open a timeout, and that's all. You could be able to ask the network for more than that, and so you should be able to make a co-design. And what is important is about embedding intent. And if we are talking about human in the loop, the human has to know what's going on and has to find a way of expressing what he or she wants in a way that doesn't make, it's not ununderstandable and untraceable for him. And that brings me to something that I like, which is the dialectical way of managing networks. This guy at the bottom is, do you know who he is? Hegel rings a bell in your brains. The father of dialectics, the idea that there is in the evolution of human thought, there is a thesis when you affirm something. In this case, is what we want from the network. And there is an antithesis that is what is against, or the environment in which you had to fix and what you had to find, which is, in our case, is precisely the constraints. I mean, somebody wants anything from the network, but you have a set of network management constraints, and you have something that is very important, which is SLA enforcement for you and for the others that are using the network. Everything should be expressed as antithesis and antithesis in a human understandable language. And what brings progress and what makes humankind evolve is precisely synthesis. How do you achieve conflict resolutions among the different action requests with the management constraints, and something that is important, something that at the end is understandable and traceable by humans for the auditing purposes. Why? This can be done by a cognitive method. This can be done by an artificial intelligence, but what you get at the end is something that has to be understandable by humans and has to be endorsable by that human, because at the end, the responsible entity for whatever happens will be that human. And this is very important. This is a way in which we are trying to evolve in the, we are making some experiments about these expressions of intent, how those expressions of intents can be made compatible by machine learning methods, well, by machine learning, by artificial intelligence methods, and how we can run these synthesis applications. And I think this is one of the big challenges that we have in the case of network management, if we want to achieve this automation goal. Well, just to finish, something that is important, I was thinking about software management. We have to think software. Think software, and think software. There will be multi-language. There won't be a single language for everything. Multi-solution. Don't try to look for a single solution that is going to be the only one that is to satisfy everything. Multi-thread, multi-process, whatever. And take into account that there will be someone in the loop, a human in the loop always, always. We have to be aware of that. There will be a continuum of solutions. There will be even not a few solutions. There will be mix and match as you need, as you please. Go for it. That is something that is extremely normal in software space. In different companies, I mean, 2 insurance companies, they are probably running basically the same kind of main pieces for software, but then they have their small pieces running, and they have different ways of connecting them one to the other, and they have different ways of getting reporting, etc., and this is very important. What is important as well is that we take advantage of what is brought by the technologies themselves. So we have a much smoother migration path. Don't be obsessed about being radical and say, no, we are going to do this right now, right here. And leveraging something that is very important here is that is about people. And this is something that I heard very often is about that you had to retrain we had to retrain the people, etc. I would say that what we had to do is to give most of them a little bit more freedom. Because many, at least in my case, I know many of the people that are in my company that are managing the network, they would be happy if they were allowed to run their own scripts. Because they have really smart things running right now to save them time. It's not about retraining them. It's about allowing them to show what they know. Something important is that we are talking about systematizing the whole thing. It's not a war between specs and implementations, standards, or open source. We need consensus, and that's slow. That's slow by definition, because in the moment you put a couple of humans discussing, it takes time till you get them in agreement. If you take a couple of 100 humans together in a room, all of them with an opinion and so fond of listening to themselves as who you all are as a community, is something that is complicated. Slowness is not in the how the process is, but it's in the And finally, try to avoid reossification. Keep it whatever you want to call it, ductile, moldable, plastic, elastic, whatever. Let's try to avoid, again, to invent the one and only solution that fits all problems and get into more trouble, because next time probably there won't be this revolution on time. And I think I'm done. Yes, thank you.